Have you ever wondered how a tiny bullet can cause such a massive impact? Or why a spinning ice skater speeds up when pulling in their arms? These intriguing phenomena all boil down to two fundamental principles of physics: momentum and the conservation of energy. Imagine a game of pool where a cue ball strikes another ball, sending it rolling across the table. That's momentum in action. Defined as the product of an object's mass and velocity, momentum explains why a moving truck is harder to stop than a bicycle. In essence, momentum is the measure of an object's motion. Now let's take a leap from the pool table to a roller coaster ride. Have you ever noticed how the coaster builds up speed at the bottom of a slope and slows down at the top? This is an illustration of the principle of conservation of energy. This law states that energy cannot be created or destroyed, but it can change form. In the roller coaster's case, potential energy is converted into kinetic energy and back again. Momentum and conservation of energy are like the yin and yang of motion. They are interconnected, and one cannot exist without the other. For instance, when two objects collide, their total momentum before the collision equals their total momentum after. This is known as the law of conservation of momentum. Meanwhile, the energy involved in this collision will simply change forms, but the total amount of energy remains the same, illustrating the conservation of energy principle. So, to sum up, momentum is the force that keeps an object in motion, and it depends on the mass and speed of the object. The conservation of energy, on the other hand, asserts that energy merely changes forms, and that the total amount of energy in a closed system never changes. These principles of physics not only answer our initial questions, but also explain countless phenomena in our daily lives. They remind us that every action has a reaction, and nothing in nature goes to waste. So, the next time you see a soccer ball flying into the net or feel the rush of a roller coaster, remember the invisible laws at work: momentum and the conservation of energy.